How about that? Thank you, Jeff. Oh, thank you, Jeff. Jeff saved the day. Wow. All right, let's start over. Golly. Man, it's hard. I try. I really do try. Well, thanks for being here, everybody. Happy Monday. What a weird stream time. So I went through this whole explanation while I was talking to myself, I guess, about how about what went wrong this weekend with my planned streams. It was mostly an underestimation on my part of how much I would have to, about how much would be going on with a bunch of boys at the Whobbit Hole. I thought it would be, they'll do their thing, and I'll be able to do my thing, and I kind of thought it'd be fun, but boy, you talk to yourself too, Nick. Anyway, so it got a little busy, and then right when I thought we would be streaming yesterday, we had to come home. It was time to come home, and I didn't know what time we were coming home, so a little bit of planning on my part would have done a lot there. And then got home, and my mom was here and had made dinner for us, and had some bad news about her sister and her health and stuff. Anyways, so things have been kind of sideways, but that's okay, right? That's just life. That is just life. And then thank you to everybody who was sending me messages that my microphone was off. I do appreciate that. Oh, man. Okay. All right. No audio. Gotcha. Okay, so here it is. It's Monday. I am at home. Had the day off work, but couldn't stay up at the Whobbit house. I would have loved to have stayed up there and kept working on things. But we had all these boys, and we had 2 cars, and I had to drive them home, so I didn't want to drive them home and then drive back up there. So I thought, I'll work on some stuff at home. So what I've got sitting here on my desk is my Lumen Cache. Monday. Can't trust Monday. Hey, how's it going, Dan? Tevi is here. So, let me remind y'all, if you haven't been around or paying attention much, of what Lumen Cache is. Lumen Cache is this lighting system that I got for the Whobbit house. Can't see my screen. There we go. Oh, my shirt is green today. That's fun. So Lumen Cache, basically, it's a DC, or I think more accurately, it's a power over Ethernet lighting system. And we've had Derek, who's the CEO guy who invented it, came up with it, is the driver behind getting it to market and things. Super sharp guy. He lives in China. We've had him on the stream before. Talked to him several times. So I've got a bunch of equipment. I don't have all of it because it's still COVID stuff, I guess, and things are hard to get moved around sometimes. But I've got enough that I can get started. And if you know me, I know. Thanks, Creative. I missed you guys yesterday. It was a crazy day, crazy day. Anyways, so Lumen Cache is it's actually fairly simple now that I'm getting into it, and I'm learning about it, and we're gonna learn some more about it today. We could do this the easy way and just get Derek and have him come on the stream again. But I thought, let's just play with it. Let's just poke around. Boop, boop, boop. All right, Patrick. Thank you for subscribing, Patrick. We're going to do the train with a semi-truck horn. Whoop, whoop. Arun, thank you. Namaste. Or namaste. Or namaste. So we're going to just poke around with the voltmeter. We're going to measure some current. We're going to look at power usage. And we're going to connect up some LEDs. And these aren't strips. These aren't like WS2812 LED strips. These are like chip on board bulbs. So COB, C-O-B, chip on board. And they look like this. And we got these working before. They actually are nice and bright, and they don't use much power. So I like them quite a bit. They're very, they're very small. They're diverse is how I look at them. I look at this and say, okay, I could make any light fixture I want with something like this, right? Great excuse to disappear from the wife. Nice. Love Island finale. Oh, gosh. Yes, Martin, you're welcome. We saved you. Ew. Sounds awful. Oh, J-A-A-K, how you doing? Second time was correct. Namaste. All right. So this is the board here. This is one of them. I've got 3 of these. And the basic rundown, this is my basic rundown. Derek will probably give you a better rundown. It'll probably be more, don't get as hot as standard AC LED bulbs. No, they shouldn't. These won't get hot hardly at all. Well, they shouldn't. We'll find out today. So this is it. And I looked at the backside of it. It's really just it's a pretty simple thing on the back. It's mostly just a bunch of connections. There isn't any components to it. There's no resistors, no nothing. It's just making a bunch of connections. And then all of the electronics stuff is inside these little things here. And these are all modular. So this thing is for a switch. So this is how this board handles an input. So if you have a motion sensor or a light switch, you have to have one of those on there. This is an LED controller. And there are 2 types of LED controllers. This one is for constant current. And this one is for constant voltage. Now, that's a concept that it's not that I don't understand what constant current means. It means the current doesn't change. Okay, well, that makes sense. But how do I find, maybe I've got this going on. How do I find a constant current fixture or a constant current bulb like this? Like, is this constant current? I can't, it's not very easy to just go figure that out. It's in my experience of the last few months. All right, Frank's here. Woo! How you doing, buddy? So good to see you, Frank. So good to see you. Thank you for tuning in. How you doing? Home Assistant is fantastic, by the way. Just getting better and better and better all the time. How did Rob was going to have what's his name on Linus Tech Tips? That's big. That's really cool. He's got millions of subscribers, so that's going to be a whole new huge audience. You get Linus Tech Tips promoting Home Assistant, and you're going to have even more exponential growth. So an LED with a resistor anywhere close is generally constant voltage. Okay, well, we're going to look at this thing. And I see a resistor. I actually see a capacitor. And it almost looks like a little, I want to say a transformer, but look at this little coiled thing here. Oh gosh, turn that light off. So you guys are not going to be able to see very well here. So we definitely got some components here, right? We got a capacitor there. We got this little guy. It's a little coil here. And what I'll do is I'll give you the link to these two. There's one little resistor there. And so But here's what I'm thinking. Here's what I'm thinking. And it's probably wrong, but here's what I'm thinking. So, sounds like a little driver circuit. The LED itself looks very much like a COB style, right? So my thinking is I connected these little guys up to my bench power supply, and I could see how much current each one was drawing. And once I got to about 9 volts, we'll do it again here in a minute, but once I got to about 9 volts, I went all the way up to 22, and the current stayed the same. So I'm wondering if I can set the constant current. The other problem is I've got a lot of these constant current. I've got a lot of these, and I don't have so many of these other ones. And I think I need, if I had constant voltage ones, it would probably be easier, but I'm going to see if I can make some of these work as constant current. And I'm thinking hey, Sir Goodenough, how's it going, man? Thanks for being here. I'm so sorry for yo-yoing you around this weekend without streaming, and maybe this time, maybe that time. I'm sorry, dude. He's such a good right-hand man, and I left you hanging all weekend. I apologize sincerely in front of all of our friends. To keep Twitch quiet. Didn't expect you to go live. Awesome. So anyways, I'm thinking if each one of these, so this constant current and the current that you can adjust the current, and it's something like 200 milliamps or something like that, like 0.2 amps, I think, something like that. So I'm thinking if I put a bunch of these in series, what if I put a bunch of these bulbs in series? Then, and I got to the point that the current, that a normal current for these bulbs is reached at a lower voltage, right? Like, what if I can get it so that they reach that current, and the driver only has to give them, 12, 15 volts. How fast will that explode? Right? This is what happens when you learn a little bit about electricity, and then you think, oh, I know what I'm doing. So that's what I'm thinking. And now I'm going to wait for Quindor to tell me why that's wrong, which is fine. That's good. That's good. But I think I might try it anyways. Okay, so I turned on my bench power supply. I'm going to connect up one of these. I'm going to need to keep putting my glasses on back and forth. All right, let's see what we got. Quinn in the dock. Love to see a stream about power supplies and the DrZzs. How do we not fry our DrZzs or supplies or start a fire? Oh, we can talk about that some today, Ryan. LB Retro, thank you. Your bill. Hertfordshire, UK. Nice. Thanks for being here. Hope one of the LEDs doesn't burn out. It might. It might. We're starting fires. Starting fires here, pretty much. All right. So I'm going to connect this guy up. Put the plus on the plus. Put the minus on the minus. Don't really like how close this gets, but it'll be okay. All right. Now we'll turn it up. And 0.1 amps. We're at 0.1 amps. 0.3. Okay, so it's at 0.2. And if I can go all the way and keep going up, keep going up, keep going up. So I keep going up on the voltage and it stays the same. It goes from 0.2 to 0.4, 0.6 to 3. And if one fails, the rest can blow. Yeah. Queuing up Firestarter by The Prodigy as background music. Nice. Sod's Law. Sat waiting for the stream and nothing. As soon as I leave and collect misses from the work, the stream goes live. Oh, sorry, Tony. Hey, Automotive Solutions, how's it going? Are you in Canada? Is that you? Not all the wires and the components can handle the strains. Yeah. All right. Here we go. We're going to play. We're going to play. So, so the current has to pass through each one. But will it not stop? Ah, man. It won't stop at a certain... Well, no, if it'll stop. But if I can set it... If I can set the current output on these, I don't know what that's going to do. I'm just wondering if I can set the current output. Where's the fire extinguisher? Hey, what are you doing here, Blade? How's it going? Ooh, listening while you build robots at work. Man, that sounds like fun. Anyway, we're going to play. We're going to play. All right. Here's what I'm thinking. I want to test a couple things. Another component to this whole thingy here is this little guy. Actually, I put it under here. It might be easier to see. 116 volts, 232, 348. So the auto scales to max of your driver, still 2 milliamps. If one then fails, no worries. Voltage just goes down. If I put them, so I can put them in, I want to know what, like if it gets to 0.2, if it gets to 0.2 amps and it stops and it only needs to be 12 volts to get there, or 14, 15, somewhere in there. Because that's what this thing is going to do, right? Ooh, why not add a current limiting circuit? I think that's what it has, but yeah, right? I'm trying not to add, like, I don't want to get in and start soldering in my own resistors and stuff if I can help it. But anyways, I was thinking, if this thing gets to its max current and it only has to give these LEDs 12 volts or whatever to get to that max current, then that should be fine. The alternative is help me find some CC is current limiting. Oh, that's what it says on there? That's what these are? Yeah, that's why it's L2CC. So 75. So I can adjust this. This can be adjusted to put out 75, 150, 300, or 600 milliamps. Yeah, so there you go. See? And that's what I'm saying. Constant current. So yes, limited current, right? Okay, so the other thing I need to know then is how to adjust the current on these things. And I don't have a manual for this thing. And the problem is if it starts out at 600, how can I test it? How can I test it? How can I test it? All right, so this, I'm going to put this thing here. So this cord corresponds to this port. So I'm going to put that as the in. And then the other thing that this thing does that's pretty cool is you can do switches. You can do switches on the end of the circuit. So if I just go here as out, can you see that at all? If I put this on the out, and then this is the last LED, so we'll leave that in. And then we can plug this in to this switch. I don't see an in or an out, so it probably doesn't matter. Okay. So I've got here this light fixture that I rigged up to hold those little kinds of bulbs. So I'm thinking, why don't we just turn it on? Any reason? I mean, what's the worst thing that can happen? Boom, right? The only thing that may mess this up is these LEDs things have their own integrated CC drivers. I don't think these have their own drivers, but how do I tell? I mean, they must. It says CP. Here, let's find these on AliExpress. You guys that know more things can. But you're right. You're right. They may, Guido. You may. Constant current source gives you always the same current. It is the same. The current should not be independent of the voltage. Right. The voltage changes to keep that current constant. Okay. What in the world are we doing? Hey, Tech Turtle, we're blowing stuff up today, my friend. I think we're going to probably cause some destruction. Symphony of Destruction. All right, thank you for subscribing. You get a unicorn. Oh, it's Blade. Yay. Oh, I already did the choo-choo train, Blade. I already did it. So one of the main points here is I want to use what I have. So if things are like, oh, this would require this other thing, then the answer is probably no. Okay, here, you guys can check these out. All right, this is what I have. And if I need to get something else, I guess let's find the other thing that I need to get. See, these don't have a controller. These don't already have a... Because they're supposed to just plug in. I would think. Oh, maybe they do. Maybe they do already have a driver. Is that what that all is in there? Constant current source is the best way to power an LED. Great, Erwin. Now how do I find an LED that I can use? More like a ship train. You ideally want LED without any integrated electronics. Well, can I take these electronics off of here? What if I did that? Oh, geez. What if I just took these? I don't want to take all this apart, but... So how do I find some? Yeah, they do, right? Constant current, ideally, yeah. So they do. So you're right. So these are not going to work very well with constant current. But could I still use them? Maybe they're not the best. Maybe I shouldn't. But what if I do? So what I wanted, they're not easy to open. You're right. They're like all baked in silicone and stuff. So, I'm not going to open those. You're right. That was just, me being me. Taking them off would be problematic. So you partly to reverse engineer. Okay. So then let's just, I just need some cob LEDs, right? But even this, like, is that what I want? Like seriously, like this? Is this what I want? If it blows, bad for CC. If not, seems okay. Oh, I love it. 2 in series for 24 volts. I actually have 48 volts. What's the worst that could happen is they're not balanced voltage over one goes up. I know I shouldn't put my finger in that socket, but what if I did? This is why this is so much fun. Yeah, I mean, these kinds of things, right? We don't want to fire. Yeah, probably won't. Cob LED is the solution. So these kind of things here. Oh, and these have the watts on them. So if I had these kinds of things. So if I had these, because really this is nothing but a plus minus tab and an LED, right? Grab a hold of someone else before putting your finger in the socket. Then you're all set. Do I feel lucky, punk? Okay, I want to play with this and see. I just want to see what friggin' happens. I just want to see what happens. Should know the current of this board. You cannot change it. Yeah. Well, when I hooked it up to my bench power supply over here, they never went really above 200 milliamps. The trick is let's connect them to the correct. Let's do them the right way first. Fine. Oh no, the problem there Wait, if I put it there. Oh, here's what we need to do. Yeah, this one thing we need to do first. Okay, we're going to plug this in. We're going to plug this in, and then we're going to turn it on. Okay, we're going to actually fire up this. We'll come back to those, and I probably will need to get some of those or something like it. All right, I just turned on my power supply. I've turned on my power supply. I now have my Lumen Cache thing doing its thing. Okay, we got some blinky blinky going on. What I want to know is what is my voltage here. And I'm pretty sure it's going to be 48 volts, but I want to check. Why does my voltmeter say it's already got 9 volts? Okay, that's better. All right, so that's not giving me anything there. Might be this. Okay. It's probably waiting for me to program it. This is the problem with... Oh, yeah, look, now this thing's lit up. Okay, good. Now we got something going on here. That's only 8 volts. Why? Okay. If I... Well, now it's none. Now it's 8. Okay. Let's try this guy. 5. Aha! 14. That's so weird. Why would it be 14? This is a 48 volt power supply. I wonder if I hook something up, is it gonna give me more than that? Oh. If I hit the switch, it's not doing anything. Oh, yeah, there it goes. No. Yeah, that's when it's off. Yeah, it gives you 14 volts all the time. And then 48 when it turns off. I know you guys can't follow exactly what I'm doing here, but I'm pressing the button. So I got this light switch. Let's zoom out. So I got the light switch here, and I'm watching the voltage change. So when I turn it off, it drops down to 14. When I turn it back on, it goes to 44. So that was one of the things I was concerned about. So I thought that I could just hook this up to these 12 volt LEDs. And I thought for some reason in my head that this would be 12 volts coming out of here. It is not. It is not. It's going to be whatever the power supply is, which in this case is 48. And I don't really want to have to step that down. All right, so now we got 8 volts and then 0 volts. 8 volts, 0 volts. 8 volts, 0 volts. And right, the way I've got it set, no matter which, I touch the button and it changes. Doesn't matter which one. Now, why wouldn't it go to 0 when it's off? Good question. That's a very good question. This may end badly. If the internal driver gets more voltage, it will use less current, so the driver will get more voltage. It might run away. Oh. CV should transform it to whatever it is set to. It's a bit worrying watching Z's reach inside RG45 and pull stuff out. Let's vote if it works or not. I have a few sets of cobs. You need CC for them for sure. So this is what I thought I was getting. And I guess, this was the heat of the moment. When because I searched for cob LEDs right? I searched AliExpress for cob LEDs and I get this page. So I got this and I thought, oh, those are perfect. That'll work. No, not what I wanted. What I actually wanted is, so I do have some cob strips. That's actually good. But what I want is those others. I need some like this. But why does it say 12 volt? Why does it say 12 volt? Isn't it going to just, I mean, if I wanted something like, I'm trying to think of what, so 140, I need something I can put in these fixtures. Can you hear that power supply? It's loud. So 30 watts. It's kind of a lot. I need smaller. Yeah, like this. So something like this. Tells the forward voltage. The voltage that is going to drop over all the LED. Cob LED configuration ends up using about 12 volts at the given milliamps. Oh, okay. Yeah. Should connect a load, in this case LEDs, with a total of 200 milliamps. Yeah. And that's why one of these I think is going to be, like if I connect one of these would be okay. Well, there's only one thing to do. Right? Connect it. I thought the sound was coming from my truck. And it was still ringing. Make it blow up, make it blow up, make it blow up. Okay. Let's turn off. Well, right now, let's see if there's, well, I guess I could do this. All right. Should we just, I could just touch this here. I mean, I could just stick that right there. What do you think? A hotel in France on your way to Spain. Lucky, guys. How's it going, by the way? Turn it up until it explodes. I think this will work. I think this will light up. We'll just, and since I can, I just kind of got my hand here, I can just control it, Blade says do it. All right. Everybody wants to see the F key. Okay, here we go. We're going to do it. We're going to do it. Okay. This is the correct way. That looks positive there, negative there. Okay, here we go. Ready? Worker explode time for reals. Okay. So I touch it there, nothing happens. So now I'm going to turn it on, basically. Still nothing happens. Well, that was anticlimactic. Let's try this. Let's make sure this is going to work, though. Yeah, that's positive. Positive to the positive. Nothing's coming out. Nothing's coming out. Which is weird because I could measure the voltage there. Let's put that back on. Measure that voltage. It says it's 8. Eight volts should be enough to turn it on. Well, that might be because of all this other circuitry on here, huh? That's a bummer. That is a major bummer. Okay. Shoot. Well, we could try the constant voltage ones, but the constant voltage ones, the problem there is it's going to be so low. Like the constant voltage is going to, or it's going to be so low, it's going to be 48, right? I mean, we already looked at that. The constant voltage is 48. So, and it's probably pretty hard to find. Okay. Real excitement is when you check Y. Man. And I didn't, did I? And I didn't bring home those, I have those cob strips, and I didn't bring them home. Oy, dummy. It normally lights with 8 volts. Yeah. So let's go back to this. Because when I put it on the bench power supply at 8 volts, it turns on. Okay. It could be, though, what if it's set to a constant current? You know what? What if it's set to a constant current and it's set to like 75 milliamps? Then it wouldn't work at all. So I got some switches here. Let's play with them. Let's change that. Let's see what happens. Okay. A lot of this is you guys watching me see what happens, but you can't really see what I'm changing. You know. Still 8 volts. Still 0 volts. But I changed something, so let's try again. Let's put a bulb back on here. And if it's at 150 milliamps now, it should work. I think the 8 volts is when it's off, and I think when there's nothing connected to it, it's not going to show anything. Let's try this. No? Okay. And still no. I don't think that means on. I think that means off. I'm getting braver about just pushing on there. Okay, so that's that. Let's try switching these switches to something else. So there's 2 like dip switches on here. Isn't that what you call them? Dip switch. There's 2 switches on this controller. I put them. It started with 1 up and 1 down. I switched it to both up, and now I'm going to switch it to both down. My guess is, and you know how good I am at guessing. My guess is it's got 4 possible currents, right? It's got 4 possible currents. My guess is, let's actually I want to turn that one up and that one down. My guess is the safe thing to do would be to set it at the lowest possible current out of the box. So it was set to, or no, well, maybe. Anyways, I think it's got 4 possible scenarios with these 2 switches, right? You can go, there's a 1 and a 2 switch, and either one can be high or low. So you got 4 possibilities. So it was set, I've checked 2, I've changed the switches and checked 2. I'm just change it again, I'll check it again. Do that green on CC, voltage goes to max supply. You can configure the unit to supply constant voltage to the lights instead of constant current. Just change the power supply to match the light voltage output. Right, Wagner, right. Which is what I'm trying not to do. And I may have to do that. I may just have to, instead of using a 48 volt power supply, I may just use a 12 volt power supply and then it'll work. Right? I just don't know how much voltage I'll lose. But if I did lose a little bit, it wouldn't be that bad. They're still pretty bright at like 10 volts. Is it gonna damage the lights if I use it at 10 volts for a long time? I don't know. The maximum voltage the driver can output, 48 volts is the size of the power supply that's supplying this whole thing. So that's as high as we're going to get. All right, so I changed that again. I changed the dip switches. I I still think that 8 volts means off, but and this, I'm trying to play with this constant current driver because I have a bunch of these constant current drivers. I think what I'm going to need is to get a bunch of constant voltage drivers. LED isn't activating the sensing circuit of the CC driver. Probably true. I think you're right too. That's why it's not turning on at all. Yeah. Okay. Well, we got one more scenario to check here on the dip switches. I was hoping that because it was a constant current thing, if the light wouldn't, the light's going to use at least 100 milliamps, it looked like. Not other drivers, yeah. CC LEDs, not other drivers. Well, I've got these lights. If I had these constant voltage these are the constant voltage drivers. These, though, just pass through whatever I've hooked up here for the power supply. So if I hook up a 12 volt power supply here, then these will pass 12 volts out here, which is actually maybe not the worst thing ever. Maybe work just fine. That'll work for these. So that's what we're gonna get. We're gonna get to that point because I've got a 12 volt power supply around here somewhere I can play with. All right, so this is change that dip switch last time. Let's try it again. I'm getting really nonchalant about it. Woo! Did you see that? I got light. Scared me. That scared me. Did you see it though? I got light for a second. Okay, let's try it again. Maybe it'll still work. Maybe I blew it up. Okay. Now I'm scared. Oh, I see a spark, like. I see sparks. 32 feet of UTP, not 12 volt out. CC does not have that problem, yeah. 98 watching, 15 likes. Come on, man. Oh, yeah. I wonder if this one still works now. We're going to have to check it. Because, did you see it? I mean, it did get light for a second, right? Not designed for lots of CV lights, since it needs high voltage under the cables to handle loads. Yeah. Yeah, that's true. So it wouldn't do me a lot of good to have a 12 volt power supply. What I need is the right light bulbs. Oh, and we have one dead soldier. Magic smoke. Poof. This one is history, my friends. This one is history. I even saw the little thing burn up in there. This one is history. Oh, wow. All right, let's see if you can appreciate this. So, wow, that's cool. Okay. We made some destruction. We made some destruction. All right, let's see if I can focus. Let's focus that. We want you guys to see this. This is good stuff. The circuit did blow, yes, sir. It did blow. But now, maybe I can take it apart and just use the cob. Odin's son. God, LED lightning. Lightning. Oh, man. Okay, let's see. Let's find this camera and adjust it so you guys can see it. So I want you to be able to focus. Autofocus never really works well on this. Okay, there we go. All right. So here, this one is the good one. This one is normal. That component, not the transistor, or not the, not the transistor there, but this little, or capacitor, I'm sorry, not the capacitor, this little guy over here, whatever that is. Okay, but get a good look. Get a good look at this, because this is nice and uniform. Okay, now let's look at the one that exploded. First thing is, that ain't right. See that? It's got like a shiny part, where I think it kind of delaminated. Okay, this one's all good. This one kind of delaminated. Right there. There. You can see that. Okay. And then the other part is this little guy over here. And I'll put this other one back up here so you can compare again. That's what it's supposed to look like. Oh no, wrong side. Okay, that's what it's supposed to look like. That's what it looks like now. I actually think it might even have come off the board a little bit. Yeah, that was fun. Okay, well, one dead soldier. Bum, 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 ba-dum. Okay, next. Let's go back down here where you can see again. Da, da. Okay, done. Well, what did you think about that? That's part of the rectifier. Was that a diode? Black is down. I don't know. Anyways, okay. So, maybe though, maybe. Let's go back to the idea. I think maybe I didn't. Let's see. I'm going to dig this dead one out of the trash because let's cut into it. I mean, what do we got to lose? Nothing. We got nothing to lose here. So we're going to cut into it. And I'm going to go down to where the contacts are. Right on the cob itself. We'll just bypass all this nonsense circuitry. And we'll just go straight to... Actually, I don't know that that's the connections on the LED. No, I don't think it is. That looks like it's that's the other. Oh. Okay. Oh. Oh my. Well, it wasn't quite so hard to get apart as I thought. Look at that. Just kind of came right off. So, now I see on the other side of it, I wonder if this... Oh yeah. Look at that. So I can just peel this guy right off. And there it is. There it is. Now I've got access to just the circuit board. Way less than 200 milliamps. Magic smoke. Add some blood and cutting mishap. Might as well get the razor blade out. It's really, if we're going to make a trip to the ER, let's make it worth it. They probably do want less than 200 milliamps. I agree. So it would probably be worthwhile here. I'm going to break this thing right off. Okay, so now I've got this whole thing broken off. So here's all the circuitry that was at the bottom of it. Pew! And this is just the cob now, for real. Okay. And actually looks like when I saw that sort of delamination, I think it was just probably heat from when I blew that little guy up. That kind of separated that silicone a little bit. It doesn't look like it did anything to the actual cob here, the actual LED. So, with this in hand, we may be able... Is blood a good conductor? I don't know. We should find out. This way it will burn out over time. After an hour or so, they were dead. Oh. 50 milliamp limit and then slowly raise the voltage. Ooh. Oh, okay. That's a good idea. Gosh, you're so smart. Okay, so I set it plastic or glass housing. It's like a silicone. It's like a silicone. Driver and measure how much current the LED is taking, and then remove the driver and configure the driver setting of the board to match the current. Trick is when I start dialing up the on my power supply, if I dial all the way back on, which button is that? Do I have to have a load connected for the constant current to work on the power supply? Because I can't seem to dial it in. Oh well. Okay, let's go back to this. I actually didn't take note of which side was positive and which side was negative. It looks like that says negative. Looks like that says negative. You do need a load? Okay. So I'm just going to turn it all the way down. I've turned the power supply all the way down. So I'm going to connect this up and then I'll start slowly dialing up the current. Let's see if I can make it so y'all can see this. Let's move some stuff. Okay. There she blows. Okay. That's it. Nice. Ouch. Okay, I looked right at that a couple times, so I can't really see right now. Okay, that was good. So what I discovered there was 150 milliamps. These need 150 milliamps to not flicker. Okay, so the problem now is how do I set this constant current? Yeah, I think of my LED driver. So I was just using my bench power supply for that one. More power, Igor. Oh, and the voltage was only like 8 volts. It was only about 8 volts. That was it. The yellow piece will burn over time. This, you mean the LED here, this guy? I mean, if I set it to the current that it's meant to be used at. Bright like the sun. That thing was bright. Is it supposed to be that bright? I don't know, man. I don't think so. No, it is, because it's like a... Well, maybe not. because it was a... Oh, let me turn it back on for a second. Yeah, that's at 1.75 watts. So 1.75 watts. And if I remember, these were like 3 watts. So, oh, these big ones are 6 watts. AC 220, what? DC 12 volts. This is what I got. So those can take 6 watts. Why would they say 6 watts? It's only like not even 2. But that's great as far as watts over the 48 volts goes, right? Those are pretty freaking bright. I'm blinded. Blinded. These are the 3 watts, the smaller ones. And I have a bunch of those too. Constant current should be 150 milliamps. Yes. So but now the question is, my driver. What if my driver is set to deliver too much? I think it's set to 300 by default. Let's turn it down. Let's turn it to low on both switches. I mean, what's the worst thing that's going to happen? Let's turn it to low on both switches. There should be a... Retinas grow back, don't they? And that was pretty close. Yeah, Guido. I mean, so it was about 150 milliamps. Do not use the driver of these LEDs. Just use this LED itself. Right. Hey, Okert. Yeah, Monday stream. Just feeling a little fancy. In contact with air, it will burn. Oh, really? Oh. Well, it does have a coating on it still. I think. I mean, it's got like a glass back. This feels kind of... So what I should do if I do that is if I cut these out, I'll leave the silicone on the outside. That's what you're saying? Touch the LEDs to the CC driver with the LED connected. Yeah, that's what I need to do. That's what I'm afraid to do. No. All right. So to do this thing, we must remove this thing. Okay, back to this. Now I'm going over here. By the way, did you guys notice all the boxes behind me? So we got a bunch of orders going out today. So if you've ordered stuff, it's probably back there. Especially if you ordered it over the weekend because I wasn't here. Okay. Oh, Mrs. Z's is home just in time to call the fire department. I think I have to go I have to do something for her, like drive somewhere in a little bit here. So, but I'm going to stream whenever I can over the next few days, which means like tonight maybe again, tomorrow maybe again after work, whenever. Unload the CC driver will output maximum voltage, right? But if I load it, well, but it doesn't unload maximum voltage because we're measuring it. It was measuring 0. But now that I've got this, which should function, I'm going to mark this with a minus. Yeah, that definitely has something on it. It's got glass or something coating it. I do appreciate that, Wolf. I would not have known that. All right, so that's a minus. Okay, now we're going to use alligator clips and a couple of jumpers, tiny ones. Okay, Oh, Robert, you're late? Well, you got so much advance notice. Actually, no, nobody got any advance notice. I just decided I was going to stream because I was going to just start playing with this thing myself and then thought, well, I'm not going to just do this by myself. I'm going to do this with my homies. I really, really need to get this lighting thing worked out. Mrs. Z's was not so happy to have to take a flashlight into the bathroom all weekend. Up at the Whobbit Hole. Okay, now do this. Can you see what I'm doing here? A little bit, kind of, sort of. Don't worry, I am wearing pants. Okay. I'm gonna get this bleasted thing to work. I'm gonna get it to work. Okay. Ooh, that's live, so I'm gonna be a little careful. Okay, this guy grabs that. Let me take that off of there, actually. Come on, get out the way, you. All you bunches of things, get out there. Get away. Go. Okay. Can you see this too? Okay, good. So I have right now no idea what output current it is set to. I've got the two dip switches set to low, both of them set to low. It would make sense that that would be the lowest possible output. That'd be my guess. The lowest possible output, according to this driver, is 75 milliamps. So if I connect this at 75 milliamps, it probably won't light up at all. Or if it does, it'll flicker like crazy. You ready? Am I ready? Worky. Oh, okay, now I'm freaking blind again. Do not look right at these. Ooh. We see the light no matter what you put in. Just keep it off camera so no blindness. Gotcha. Good call. What about me? Who's going to protect me? Okay. This thing is set to read the current. Okay. But it may... So this thing's set to read the current. So let's see what it says. Okay, it says 400 milliamps. 400 milliamps. So we need to change this. Let's put it back to what it started at. Okay. Now let's see what it comes out as. 600 milliamps. Okay. Okay. So now they're both on. Wait a minute. Okay, so that is only about 10 or 20. So let's try one more setting. 0.25. And now what I need to do then is measure the voltage too. I want to measure the voltage. Okay, so definitely too low when I've got the two switches to on. When I go the default, I like that better. That's 150. That's better. Let's check the voltage now. I'm just very, very curious what voltage it's giving to get to that. Sorry for the blindness. This is freaking awesome. I'm having fun. Patient passed away. I'm having fun. This is fun. Yeah, 8 volts. Oh, now the other thing is let's turn it off. Yeah, it freaking works! And we got no volts. Oh, come on now. Now it doesn't want to come on. I can hear it making noises. It's like flickering. See that? Oh, there it goes. That was weird. Yeah, it still says 8 volts. Does that mean, though, that it's only pushing 8 volts through that whole thing? You knew the risk. Default would be the lowest. I thought the default would be the lowest, but I don't think it is, because this says it's 0.1, it's even 0.2 amps, it says here. It goes between 0.17 and 0.2. Ah, man. Gotta stop looking right at that thing. Yeah, so I don't think that lowest setting is the right setting. Or I don't think the default setting is the right setting because it just flickers like that. So let's turn it up a little. And that's better. Man, that's at 0.5 though. That's going to burn that sucker up. And then the other thing I think is this this meter is not really made to measure currents that low. Okay, so if that one's on and that one's down, that's no good. That one works fine. That one works fine. So that's a pretty good one. Down and up, down and up. Okay, I like that one. And let's try this one. Yeah. Okay. So I found the right setting for one of these bulbs. Now, okay. This is awesome, right? Okay, because of my blind spot, I can't actually tell if it says 0.3 or 0.7. No matter what, do not go to the white light. 1.2 watts, 8 volts, and 150 milliamps. Perfect. Flicker would be torchlight ambience in the Hobbit holes. You know what? I like that, Jim. I like it. I like it a lot. I like what you're thinking. Current wouldn't be the problem. I think the voltage over the LED might be too low for the driver. Okay. Come in handy when you randomly want to blind yourself. I can still see the cob thing. All right, now though, okay, we have real work to do. Okay, I have here a light fixture. Okay. Now I think what we should do. I seriously can't see. So I'm gonna cut some more of these apart. This was the broken one, remember? This was the one that I blonded. Hey, Remodel, how's it going? Blinded by the light, copyright strike. Man, nobody cares about that song. Okay. It says 9 volt right on it. What? Looks like it says 9 volts right on it. Okay. I want to try and run. Is it a dimmer also? It should. Yes, it should dim. So there's the best way that I found, and I got to talk to Derek about putting together a book or something. But if you go to, this is going to start playing this. Oh, look at that. This guy's live. That's awesome. If you go to I have to go to my library. Wait a second. Oh, you guys can't see. I'm gonna go to YouTube here and I'm gonna find Derek's videos. History. Oh, no. Oh, I know where to find it. I know where to find it. I know where to find it. Yes, exactly. 2 cobs in series, Guido. That's what I'm saying. That's what I'm saying. Has not met the minimum requirements. You may review. Correct. Okay. These guys are killing me. Killing me. Follow instructions by the resubmit. Okay. I'm doing pretty great. Remodel, how are you? Gonna go putting people to sleep and blinding them. I hope you don't blow away. Okay, so there's a few things here. Okay. Product specifications. So remote only, port devices. There's a way here to, oh, let's see. What time do I have to go? Okay. Anyways, what I wanted to know here was the, you can do stuff with the buttons. Set button, restore functions, hold 6 seconds to perform configuration macro. So there's a lot of these kinds of things. Oh, now you can't see it. So sorry. I know. Did I make it in time just for the end? Yeah, pretty close. Oh, come on. Now my camera won't go off. Yeah, well, the camera won't go off. Anyways, what I'm trying to tell you is Lumen Cache, there are some. Stream Deck is just having a fit right now. I'll just do it over here. If I can. Goodbye. What time do I have to be there? 3:30? Okay. Yeah, I have to be gone at 3:30. So I should probably, we've still got, though, that gives us 30 minutes. Blinded by the camera. Anyways, okay, so this is some of what he's got. So he's got some of these documents that kind of tell you what you can do with some of these things. Like you push the buttons to do different things. And depending on which driver you're using, I guess it does different. If it's in whatever mode it's in. So it's 3. Button toggle on off. Yeah, so this is what mine's doing. Toggles output between off 100% each time the momentary button is released. Top and bottom buttons do the same function. Okay. So I don't remember how to change that. But I'm not going to worry too much about that right now. But there is a way to dim it using this. Is anyone else singing Manfred Mann songs? I don't even know what that is. C'est la vie. I think the driver can dim automatically in the system settings. Yes, I think you're right, Wagner. I think you're right. Or there is a way to make it happen. Okay, but yes, what we need to do is we need to connect some of these bulbs in series. Swing! That means we're going to destroy a couple more of them. See my cameras. No, Stream Deck is still... The Stream Deck is having a hard time today. It's too bad. Okay, so first, let's... I think if we disconnect this thing, it's PoE, so it's going to not really be able to do too much. I guess maybe there's a little bit of voltage out there, but let's... we're going to have to do a lot of cutting. We're going to do surgery. Surgery on the bulb. Might as well. Okay, that is really easy. Anybody want an LED driver? Okay, so now I can connect this. I should just connect some wires to that, but if I go from that one to this one, and then from this one to the red one, it should be golden, right? Should. What could possibly go wrong? Let me grab some wire. Oh. Very out of focus. I'm so sorry. Yes, it is probably very out of focus because this autofocus doesn't work very well. So let's just go back up here for a minute. Oh. All right. So we're just going to take a piece of this wire and we're going to use fire up the soldering iron here. All right, firing up those soldering iron. Does this sometimes. Thinks it's on a battery and it's not. Oh, I know. There we go. Turns out if you want your soldering iron to work, you have to turn off the current limiter. Usually it's the finger oils on the bulb that burns it up, at least with halogens. Oh, and cobs are almost as hot. Oh, I see. Famous last words. Oh, yeah. Turn you off. Ooh, that soldering iron, I can smell it. Smell it. This is fun, guys. I'm having fun. Squirrel's doing the focus tasks today. Yes, and I can't do any squirrels because my Stream Deck had a seizure or something. I was all ready. So good enough. I was so ready to do stream from the laptop this weekend. Best laid plans. Okay. So now, put a little solder on the end of this. I'm going to have to unsolder this is the problem eventually, so whatever. I guess that's fine. Once I get these in the fixtures, All right. Now, we're just going to solder. Can you see that guy? Here. I'm just going to put this here. Solder that guy on there. Maybe I should disconnect it. All right, that's that side. Now, the tricky part here is exposing these. I guess that's not so bad. All right. Yep. Now this was going to be connecting to the negative on this one. Okay. There's that. Now we got 2. Okay, this is what we would actually have in this light fixture. Something to show my missus when I have cables, solder, and other stuff strewn all over my desk. See? That's how he does it. Does anyone else hear high-pitched sound? What you probably hear is the power supply, unfortunately. Sorry, Nick. I put it down on the ground, and so it's making a lot of noise. It's got a fan. It's a 48-volt power supply. It's got a big fan. So don't say squirrel. We're making progress. Oh, that reminds me. Oh, did I not put it in? Dang it. Dang it. Okay. Here goes. We are going to connect this to there. We're going to turn on our amp meter over here. I'm going to connect this to here. Okay. That's good. That's good. Now let's turn on the switch and see what happens. Wow. It says 0.6. It's too much. That's better. That says 0.4. And that would be fine. Oh, man. Let's check the voltage. Oh. The great part about this is I'm going to get some lights working at the Hobbit house, and we don't have to pee in the dark anymore. 17 volts. 17 volts. I wonder if we want to change some more of these settings. It seems to me like you just kind of flip this around until you get what you want. 0.7. This seems less bright now, which maybe that's bad. Maybe the lights are burning out. 16 volts. Yeah, they come on no matter what. And it's about 0.7, so yeah, 15 volts. So what we have, and this is going to be a little bit of a limited application. Hey, Robert, it's going fantastic, dude. Voltage doesn't matter. Current is important. Okay, yeah, fair enough. I guess I'm so used to thinking in, don't put too many volts on the LEDs. But that's when they have a driver, and what you break is the driver. So this is a new, doing just the straight, plain, blank. I'm just trying not to blind you guys, but just doing this plain LEDs like this is a new thing for me. So I have several fixtures in the house. I guess the way to, what we're going to do with these is the bathrooms. I have one fixture that is 2 of these. Ooh, is that getting hot? It's warm. 2 8-volt LEDs. It should remain 150 milliamps. It did not. Oh, you know what? I should have zeroed this. That's probably what will get it to say. That's... Oh, because now I changed it a bunch. Yeah. Well, there's 200 milliamps, basically. But this, again, this meter is not super accurate. Like, I have to re-zero it all the time. So now it's zeroed again. Now if I turn this on... Yeah, now it's 150. 120. That's good. That's really, really good. Really, really good. Okay. So this is going to be one bathroom fixture. They should get very hot normally. A little bit hot, right? Am I going to need a heat sink on the LEDs? I don't think so. Not. I mean, these, they don't come with a heat sink other than this it. But yeah, I think we're good. I think I can take these and I can put them in this fixture and we can get the whole fixture running. What time is it? 3:03? Let's see if we can get this whole fixture running before I have to take the girls. 150 is golden, isn't it? I think that's just right. I think that's just right. Man, there's a lot of stuff going on out there in the wide world. All right, so we got this fixture here. And I probably don't want to... I'm running out of room on my desk. I probably don't want to solder these lights exactly in there, right? I don't... Oh, you know what the other thing I'm probably going to need this for is these chandeliers. All right, so 2. How many of these do I have? 3. 2... So I have 2 bathrooms that have, or one bathroom that has 2 of these fixtures in it. Oh, here, good. Oh, good, I got plenty. Plenty of extras. Okay, good. Good. So I got one bathroom that has a 2 bulb fixture, and then 2 bathrooms that have a physician here. Intensive is awesome, Brett. How you doing? Where are you? Where do you work? So now I got these. So, oh gosh, oh jeez, sorry, everybody, sorry. 1.2 watts. I think it doesn't matter. I think it doesn't need heat sink. Yeah, they certainly didn't come with one, and these aren't, they're not cobs. They're not meant to be cobs. I'm basically cutting out the driver to use them. So, here's what I'm thinking. How best to secure these? I'm kind of feeling like I should solder little posts on the end so that you could stick in here. Texarkana! You know what I know about Texarkana is just that song. Eastbound and down, loaded up and trucking. Christus St. Michael's. Awesome, man. Well, welcome. Thanks for being here, Brett. Thanks for being here. All right. I wonder, though, if this won't work. I'm going to shut off this couple of things here. Okay. Did that sound go away? Who was saying that they were hearing the high-pitched sound? I can't remember. Anyways, I just turned it off. Maybe it's gone. 32 beds. Been using your Rob instructions, working on Christmas lights. Awesome. Awesome. Well, it's a good hobby, man, and it's the right time. This is the time to start getting them up. Okay, so what I need to do is I need to I know what I need to do. One thing I need to do for sure is in this fixture, it's got these wires coming out, right? We don't need a ground. Who needs ground? Nobody needs ground. Lame. All right. What we do need, though, is plus minus. So we're going to say this is going to be positive. Over here is going to be negative. So then we're going to hook our positives and negatives together on the middle here. All right. This is going to be how we series these bulbs. Making sense? Everybody watching? Don't need nothing but a good time. Oops. Somebody give me a warning when it's time. I got 13 minutes before I think we need to probably wrap up. Oh, I shouldn't turn that off. I should turn it back off. Gotta get my soldering iron heated back up again. All right, so we got those. We're just gonna put a little twisty do on there. Want to hold together. Okay. So then this will be our positive. Just gonna put that there. And this will be our negative over here. Great. Now we got to get these to connect in there. So, how to do this? Maybe I could just melt it right on there. Let me see. Try to get this to come off. Okay. So I got those to come off. And negative is going to be over here. Okay, let's turn this around. You guys see anything that I'm doing? Yeah, kind of, sort of. Wire nuts, yuck. All right. And I guess I could just... Oh, I know what I need to do. Do it right. Z's, do it right. Fine. Fine. Bing! You rang. Part of the problem is I try and go fast because I'm on the stream and stuff. Ow, that's hot. Okay, get that off there. And where'd the other one go? Anybody see that other voltage regulator I tore apart? There it is. It's not. Is it not a voltage regulator? It's a. Who are you and what have you done with the real DrZzs? Is there no electrical tape in that fixture? Not yet. Not yet. Oh, the good old days when people used to harass me for using for all kinds of things. They probably still do. I just don't pay attention. Okay. So now, whew, ouch. Okay, let's actually get this thing here. Actually set this down before somebody gets burned. It's all fun and games until DrZzs catches his pants on fire. I almost just did because this little thing I'm soldering flipped off and went on my pants. Okay. Okay. And then just need something like this. I'm going to take this. Here, stinker. Okay. And then we're just going to put this on here. Okay. So now we're going to basically have these cobs with little tabs on them, or little rods. Because I already put ends on the wires. I honestly think when it comes time, I'll probably just solder. So when the light bulb goes out, I'll have to resolder it. I'm going to make it so nobody can ever live in my Hobbit house but me. They won't even know how to change the light bulb. Come on, you stinker. Took longer than I wanted it to. One down, one to go. Ooh, this one's still got the silicone on it. And I lost my other little rod. Where has my little rod gone? I'm regretting singing that song. 7 minutes. Okay, 7 minutes. Thank you. Okay, one more. Need that other little piece. Where'd it go? Where'd it go? Where'd it go? Here it is. Found it. Oh man, if I get this to work, this will be such a success. This will be amazing. See, I needed you guys for this today. There's no way I would have figured this all out on my own. All right, now back to this. Okay, this is the negative, so this is the negative. So we're going to put the negative in here. Negative, and that means this one heads over to the other fixture, or the other bulb. Great. And then we're going to head over here, and here we've got the positive, right? The positive. So the negative was, that's the negative. So this is the positive. Positive right there. Negative coming from the other bulb. Okay. All right. Well, they should be sort of rigged up. You see that? Got them in there like that. Two of them like that. Okay. One more double check. Let's just do it again. Ground goes to this one. That one's on the ground. Plus here goes to minus there. Minus here should be on the minus side. Yes. And then plus side here goes to the plus there. And that goes to there. And that goes to there. Okay, I think I'm ready to turn it back on. We only have 7 minutes. 7 minutes. Okay. And let's turn the switch and see what happens. We did it! We did it! We have lights in the bathroom! Oh, Lordy! Oh, Lordy, look at that beautifulness! Oh, my blessed! Thank you, fellas! Thank you, thank you, thank you! Let's check the current again. 0.1. That's actually fan-freaking-tastic, and they're not terribly bright, which is nice. They're actually a little bit dimmer than what I would have expected. We did it, guys. We took, that'll 100% pass safety. Yeah, I don't see what's wrong with it. 4 minutes to shut off the soldering iron. It's already off. Thank you. We're gonna celebrate. Oh, I can't even celebrate. It's my stream deck. Oh, ruin my life. Okay, but we'll celebrate this way because we'll just do it over here. All right, guys, that was fantastic. Thank you, thank you, thank you. Thank you, thank you, thank you. Let's find this one. This is a good one. Is there a sound with that one? Oh yeah, there's sound. I just can't hear it. Woo! More LEDs in series for more light. That's right. Needs tape. I'm going to put some electrical tape on there right after this. All right, guys. Hey, that's awesome. That means I can move forward with installing this system and at least get it to work. Which country will it pass safety? It's DC. It's little bitty. It's itty bitty bitty. Itty bitty bitty. Oh, this thing wants to be shut off. Okay, guys. Well, hey, I'm not sure when I'm going to stream again, but my intention absolutely is to stream again before Sunday. All right? My intention absolutely is to stream again before Sunday. I don't know when, and you may not get much notice. Is it all right if I do a big, like, whatever announcement? Because I don't usually do announcements in the Discord because I just don't want everybody to, have an announcement. But anyways, I will just post a at here or an at everyone or something in Discord when it's ready. But that's it, guys. Thanks so much. Can you update the Google Calendar? I will definitely by the time I update the calendar, I probably have already gone live. I will get better at it, but this is kind of part of this is I still want to do a 12-hour stream, but part of this I want to try and get some extra streams out because we got to 100,000 subscribers, and that's pretty awesome. Email about the original quad. Keeping the original quad I was going to send by mistake. Oh, where can I send the money? Yes, Tap. Send me that email again, because I know it's in there, but it's probably buried down a little bit, and I will just send you an invoice. I can do that. Okay? Congrats on the LED victory and on 100,000. Thank you, Jim. All right, everybody. That's all for now. As always, thanks for watching. Sorry for hitting the microphone. I keep doing that. Till next time, adios. Maybe even be later today. Got to the live stream again just in time, Philip. You'll have to rewind it, though, because we're out. I'm taking off. Have a great day, guys. We'll see you maybe even later tonight. I hate to say it.